You ever have one of those moments with a chatbot where you swear it remembers you? Like it actually gets what you were talking about yesterday? Well, I'm going to let you in on a little secret. That's not magic. It's an illusion, a really clever one that has to be carefully, painstakingly engineered. And today, we're going to pull back the curtain and see exactly how it's done. And this right here is the core idea that you have to wrap your head around, and honestly, it's kind of weird. A large language model, an LLM, has absolutely zero memory. None. By default, it's a blank slate every single time. It's the engineers who have to come in and bolt a memory on after the fact. So how does that even work? Well, it all starts with what we can call the blank slate problem. And you gotta understand, this isn't a bug, it's a feature. It's how they're built. Every time you hit send on a message, the LLM has no clue who you are, what you just said, or anything you've ever talked about before. The technical term for this is stateless. And a stateless system is kind of like a vending machine, right? You put in your money, you get a soda. It doesn't remember you from 5 minutes ago when you bought chips. Every single transaction is a brand new, one-off event. LLMs at their core are exactly the same. So, to put it another way, without all this fancy engineering we're about to talk about, every chat you have with an AI would be like introducing yourself to a stranger, over and over and over again. It's just a series of first meetings that never go anywhere. Kind of frustrating, right? Which, of course, brings us to the million-dollar question. If these things are basically born with amnesia, how do we get them to remember our preferences, our project details, or even just what we said 2 sentences ago? Well, the answer is we build a memory for them. And that system engineers build is almost always broken down into two very different parts. You've got a short-term memory for what's happening right now, and you've got a long-term memory for, well, everything else. Getting the difference between these two is the key to unlocking this whole thing. So you know what? Let's do a super quick high-speed breakdown, short-term versus long-term memory. You ready? Let's put 30 seconds on the clock. Go. Okay, short-term memory. Think of this as a temporary post-it note. It's basically just the transcript of your current chat, what we call the context window. But it's small, it has a strict limit, and when you close that chat window, poof, it's gone forever. Long-term memory, on the other hand, that's a totally different beast. This is a permanent personal library. It uses massive external databases, it's got pretty much unlimited space, and it sticks around forever across all your sessions. And that brings us to the huge weakness of relying only on that short-term post-it note. See, when a conversation gets too long, that context window literally overflows. It runs out of space. And when that happens, the AI, well, it starts to break. This overflow causes three big problems. The first is dilution. That super important detail you mentioned at the very beginning, it gets buried in a sea of text. The second is distraction. The AI might grab onto some random, irrelevant thing you said an hour ago. And finally, performance just tanks. The more the AI has to reread on every single turn, the slower and clunkier it gets. So if that short-term post-it note is so fragile, how does the AI tap into that massive permanent library we talked about? The solution is this incredible process called memory retrieval. You can think of it like having a super fast digital librarian who can find the exact sentence in a billion books in less than a second. And here's how that librarian does it in 4 quick steps. First, your new message gets converted from words into a string of numbers. It's like a mathematical address. Then, step 2, the AI uses that address to search its entire memory for other memories with similar addresses. Step 3, it filters all those results down to find only the most relevant bits from the past. And finally, step 4, it merges those old, relevant memories with your brand new message, and boom, you get a perfectly informed response. The actual technologies that make this work are just fascinating. You've got things called embeddings, that's what turns words into those number addresses. Then you have vector databases, which are built for these lightning-fast similarity searches, and it's all organized with metadata stores. This is the toolkit you use to build an AI's brain. But, and this is a big but, giving an AI a perfect, permanent memory isn't all sunshine and rainbows. In fact, one of the biggest challenges in AI today is managing what it remembers. And, maybe more importantly, what it should forget. It really is a double-edged sword.
And it's a question worth asking yourself. I mean, a perfect memory sounds great on paper, right? But in reality, it can lead to some seriously strange and even harmful outcomes.
For example, an AI could latch on to some sensitive piece of information you shared once and bring it up at the wrong time. Its memory could get polluted with so much junk that its answers actually get worse. Its entire personality could even drift over time based on the conversations it's had. You see the problem? A good memory system has to be smart enough to know what's important, what's temporary, and what needs to be thrown out.
Okay, so after all that, the stateless models, the context windows, the vector searches, the risks, what does this all actually look like for you, the user? How does it come together to create that feeling of actually being remembered?
Let's look at a simple but really powerful example. On Monday, you tell the AI, hey, from now on, please just give me very short, direct answers. The system is smart enough to flag that as a key preference and saves it to its long-term memory. Then, Tuesday rolls around. You open a fresh chat and ask a totally new question. Instantly, that digital librarian finds the short answers memory and uses it to shape the new response.
And that right there is the whole point. It feels like magic, but it's not. It is a complex, clever, engineered system designed for one simple purpose: to create an AI that doesn't just talk at you, but one that learns, adapts, and actually personalizes itself to you over time. So I'll just leave you with this final thought to chew on. As these memory systems get better and better, and an AI can remember not just your preferences, but your goals, your history, your writing style, how does that change the way we interact with it? How does that change our relationship with this technology? Something to think about.